A very good morning to all of you. Welcome to session 3A on machine learning and natural language processing. Let me introduce you to the session chair, Dr. Kasan Gunawardana. Dr. Kasan Gunawardana is a senior lecturer attached to the Department of Computation and Intelligent Systems at University of Colombo School of Computing. He obtained BSc in Computer Science from University of Colombo School of Computing and then received the PhD in Information Technology from Monash University. His research interests are in the areas of machine learning, cybersecurity, digital forensics, etc.
Recording in progress.
Dr. Gunawardana, I invite you to lead the session from here onwards. Thank you.
Thank you. Thank you very much. And so this is the session for machine learning and natural language processing, session 3A. So we are going to start it now without taking much time. Let's invite our first presenter today. The paper is Period Prediction of Sinhala Epigraphical Scripts Using Convolutional Neural Networks, and the paper ID is 112. So the presenter is S. Pabasara. So Pabasara is recently passed out from Vaunia campus of University of Jaffna and completed the degree BSc honors in information technology. So let me invite Pabasara to present the paper ID 112 on period prediction of Sinhala epigraphical scripts using convolutional neural networks. So you will be getting a 15-minute period for this presentation, and thereafter you will be able to have a Q&A session to clarify the questions and things related to presentation after the presentation. Right. Thank you, and let's start the presentation.
Hello everyone, I am Pabasara Surasinghe and my research supervisor is Dr. T. Kopul, and we are from University of Vaunia. This research is related to machine learning, image processing and natural language processing, and the title is Period Prediction of Sinhala Epigraphical Scripts Using Convolutional Neural Networks. So these are the content I am going to cover here. We start with introduction. Background. So what are the epigraphical scripts? So those are any kind of text found in ancient inscriptions. So what are the inscriptions? In Sinhala we call Sellipi or Shilalakhya. So those are generally written on stone surfaces. But in addition to that, there are some copper plates and gold plates as well. So they are very important because they contain information about ancient, cultural, social, religious and many more facts. So inscriptions are very important in South Asian region because that's a very acceptable way to know about the history, to build up the civilization. So let's talk about the evolution of languages. So when it comes to the evolution of languages in South Asian region, the ancestor is Brahmi. In Sri Lanka, Tamil and Sinhala languages also evolved from early Brahmi, evolution of Sinhala language. So as you can see here, from 3rd century BC to the present day, the archaeologists have divided the evolution into main 5 periods. Those are early Brahmi, later Brahmi, transitional Brahmi, medieval Sinhala and modern Sinhala. Each period having different shapes of characters. We are going to take advantage of that to make period prediction. Let's focus on this part of figure taken from another research paper. So as you can see here, how each letter evolved from early Brahmi to modern Sinhala. Research problem. So whenever archaeologists found a new inscription, so they have to examine and identify each letter manually. That's a tedious task and less efficient and more time consuming. They make period predictions based on their knowledge. The predictions have a liability for human errors. Aims and objectives. So as a novel approach, this is more scientific way for period prediction rather than depending more on human cells manually. The main goal here is to support archaeologists to make more accurate period prediction related work. In Indian context, the researchers have done some studies for Tamil epigraphical scripts period prediction. They have used support vector machines for that. But in Sri Lanka, there are no previously done researches about period prediction in Sinhala epigraphical scripts. So that's the exact empty space we are going to fill here. So as a precise method, we are going to predict what period a certain inscription is belonging to. So input image is an stampage image. In here few letters means generally 10 to 40 letters, and the system predict which period this inscription is belonging to. Let me explain what is an stamp. So whenever archaeologists found a new inscription, firstly they make an inked imitation to a paper. It's like a carbon copy, and they use those stamp images for further analysis. So we are going to focus on Sinhala epigraphical scripts only, and also we are going to use stamp images only. And we are going to consider the time period from 3rd century BC to the present. Methodology. The methodology flows through main 3 steps. The first step is to collect data, stamp images, and do some pre-processing and create the dataset. And step 2, using the dataset, we are going to perform a data training using convolutional neural networks. The step 3 is the end-to-end process for period prediction. So as you can see here in this figure, this is about step 3, the end-to-end period prediction process. We input a part of a stamp image which contains a few letters, and after that extract each characters, and then we pre-process them, eliminating unwanted distortion. And after that, the model trained by the constructed dataset is loaded and classify the segment of each character and predict the period inscription is belonging to. In the common case, it gives output as a single period, majority letters only. But in here, it shows majority of letters, medieval singular period, and minority of letters, modern singular period. That means, in addition to the majority of letters having medieval singular features, there are some letters having features of modern singular period. And it's because the period of this particular inscription is actually medieval singular period, but with a later part, which closer to modern singular period. So these kinds of situations happen between consecutive periods only. Step 1. For the creation of dataset, we have collected 107 stampage images and categorized them into different periods based on character shapes and features. We manually crop character images using GIMP. It's an image editing software. So totally 5,160 character images were selected for the dataset. A series of transformations applied, mostly using OpenCV, for the pre-processing of character images. The manually cropped images we converted to grayscale and add some Gaussian blur to the smooth images, and we applied some threshold. We have applied some transformations using image negative techniques to transform all the character images into a common form, white letters in a black background. As the next step, contours of each characters are identified and use them to segment them from the background space. As the final step of this pre-processing, the character images are resized 64 into 64 pixels squared box. Dataset creation. We have selected 5,160 images. From those images, 80% are allocated for training and the rest are for testing. Step 2. We have followed some data augmentation techniques here to generate additional number of samples during training. As you can see here in the figure, an overview of the CNN architecture. So it has 13 convolutional layers and one channel attention module with one global average pooling layer and one fully connected layer as well. It takes the input size of 128 into 128 into 3 and produces outputs as 5 classes, from early Brahmi to modern Sinhala. Transfer learning. The convolutional layers are cloned from VGG16 model, pre-trained on ImageNet. We kept the same parameter settings of VGG16 for convolutional layers, and we have used a global average pooling layer instead of flattened operation in VGG16 at the end of convolutional layers. It's because it can show better performance with fewer parameters. Dropout and batch normalization layers are placed between GAP and fully connected layers. As the last few convolutional layers represent more class-specific features, they are fine-tuned with character images and the remaining are kept frozen during training. We have included the channel attention module as well. It is to capture the channel-wise dependencies to train and then use the learned knowledge to boost object-specific features in testing. As you can see here in this figure, the channel attention module inputs the last convolutional layer features, which denoted as F, with dimension of 8 into 8 into 512. And as the first step, the spatial information is removed from the input features using a GAP layer. Then output is produced with dimension of 1 into 1 into 512. Then, two fully connected layers are used to learn channel-wise dependencies, and they produce outputs with size of 1 into 1 into 16 and 1 into 1 into 512. As you can see here in the equations, the switch and sigmoid activation functions are used in the first and second fully connected layers respectively. In here, the beta is a trainable parameter. In the final step of channel attention module, the learned channel-wise attention, beta is multiplied with input feature F through an element-wise multiplication and obtain the output feature F bar. Step 3. The end-to-end period prediction is to input a part of a stamp-edge image and produce output as the predicted period the inscription is belonging to. So unlike the step 1, the cropping also automated here. To segment characters, 4 contours of each character are identified. The corresponding bounding boxes are extracted from the stamp-edge image. So in here also, we have used mainly OpenCV. But in this cropping, some unwanted blobs are also extracted, so they should be eliminated. To do so, we have identified some common features of unwanted blobs. So we applied some conditions to filter only the characters for the next steps. So now the character images are preprocessed as stated in step 1, applying the same transformations. But in here, the images are resized in 128 into 128 pixels to input into the loaded trained model. Then, based on highest probability, the system gives output majority of letters having the features of certain period. There are some special cases as well, when characters belonging to 2 consecutive periods. In such cases, the output is given as minority of letters as well. Testing and results. Hyperparameters are tuned for the best accuracy. So we have used Adam Optimizer with learning rate of 0.0002 with 100 epochs and batch size of 32. So we have implemented the CNN architecture in Python using TensorFlow with Keras. Google Colab platform was used as the development environment. Evaluation matrices. So mainly, classification accuracy was considered to measure the overall performance of period prediction. But in addition to that, we have used precision and recall to measure the prediction of each class. So as you can see here in these equations, how these metrics are measured. We have used the test set of created dataset to evaluate the performance. And also, Some stamp edge images were used to evaluate the performance in an automated end-to-end manner. Based on the experimental results, this approach was successful in identifying period of an inscription from its character image. We have checked how channel attention module contribute to the classification accuracy with this comparison. So as you can see here, it improves up to 90.6% of average accuracy. For the end-to-end testing, we have used 26 inscription images which not used for dataset creation. The image-wise accuracy is 96%. End-to-end testing took less than 10 seconds to predict the period of an inscription. But in here, according to the experimental results, transitional Brahmi period prediction performance is a little bit lower than other eras. Transitional Brahmi is the turning point which the script transformed from Brahmi features to Sinhala features. In that case, transitional Brahmi characters have a wide range of various shapes even for the same character. And that's the reason for the poor performance compared to other eras. And these are some test cases in end-to-end period prediction. The first column shows a stamp edge image, and the second column shows how it looks like after performing the segmentation and pre-processing. And the third column shows the predicted period, conclusion, and future works. As a novel approach, this is successful in period prediction of single epigraphical scripts with 90.6% of average classification accuracy. Proposed approach was able to detect the period of an inscription within 10 seconds. With the help of Archaeology Department, we have collected stamp edge images and constructed character image dataset, and the dataset is publicly available in Kaggle to support other researchers in South Asian region who are interested in this area. The code also available in GitHub. In the future, we are hoping to extend the dataset, adding more images, and also to improve the accuracy further. And we hope this study will contribute to the epigraphy of Sri Lanka as well as the South Asian region. And thank you very much.
Okay, now the session is open for the questions and questions, or if anybody needs clarification related to the presentation. So Pabasara is ready to answer your questions and clarify any issue related to the research.
Hi, Pabasara, it's Chamindra Ranasinghe. Just to check, you have mentioned that you use SVM. Did you early recognize that it's a nonlinear? That means, did you do logistic regression and find nonlinear hyperplanes, and because of that you use SVM? What's the background on that?
No, sir, we haven't used SVM here. We have used convolutional neural networks.
Okay, there was some mention about the vector machines there.
Yes.
I think he mentioned about the related work, right?
Related, yes.
Okay, right. Okay. So in terms of the scripts, is it like you can recognize the early Brahmin? That means you have this historical kind of recognition, or just mainly singular scripts?
Yes, sir. Only singular scripts, but they have evolved from early Brahmi to modern Sinhala. That means based on archaeologists,
right?
They have divided based on character shapes into those five periods.
Okay, right. Thank you.
You are not going to recognize the character, no? I'm here.
Sorry, sir?
Not recognizing the character, no? The period.
No, sir. Only period.
So then why you get the stamped image break into the letters?
So I think
you should have a chance to get the stamp image and process that one. So you are not going to character level analysis. Why you did this one?
There is a character level analysis as well, sir, because different periods having different set of alphabets. So we have considered all those facts based on each character shapes.
But for your this outcome, need to do this one, no? Character level. As the image, you can recognize the period, no?
No, sir.
The system?
Firstly, we went through that, but it didn't work because the character shapes are very different from sometimes.
You mean you cannot, there's no relationship between the present character and the same character represented in the previous. You cannot predict whether it's the same character. There's no way of doing that one. You mean? There's no. So the evolve is slowly evolve this character and let's extend the shape, put more stuff on the same one and evolve like that too. So there's no relationship, totally different. The same character if you look at the 5 different periods.
In here, sir, in each stamp page image we have considered, we have considered what are all the characters, different characters included in that respective inscription. So we have, based on the character shapes only, we have considered how the period.
So that means you cannot generalize for this one for any other alphabet.
No, sir. Only for single. We have.
So another thing is you break the characters into 64 bits size, but your neural network expect 120 by 120 in 128. So
yes, sir.
What is that difference?
So firstly, we have created the model for 64 by 64 into 64 squared images. But after performing some fine tuning, we could notice that when giving input as 128 size, give more accuracy. So that's why we continue with that.
Is there any reason for that one? What is the reason for that one?
So based on the experimental results, it worked like that. So in the future works, we are going to recreate the data set with more images. But in that case, we are going to use 128 size of images with some higher quality.
So other thing you said you contributed this data set to the Kaggle. Is that?
Yes. Yes.
Okay. That is available?
Yes.
With your code also?
Code is available in GitHub. Yes.
That is publicly available?
Yes.
Other thing is you did transfer. Hello?
Sorry, sir?
You also mentioned something wrong. Hello?
Sorry, sir, I couldn't hear you.
So you use transfer learning, you said, no? VGG60.
Yes, VGG60, yes.
So how much data you use to retrain the model?
So totally it's 5,160 images.
You didn't rotate and you didn't put some noise and expand the data?
Yes. Yes. Data augmentation. Yes.
Augmentation you have done?
Yes.
So the final data set, what is the size?
5,160 images.
That means after augmentation?
No, before augmentation.
After augmentation? What is
we haven't calculated that.
But you maybe 10 times bigger than this one?
Yes, because we have applied some transformations in there. I think 7
transformation.
10.
What are the transformation you did?
Rotation, shearing, shifting, like that.
So rotation will not affect the character?
Yes, but maybe a few rotation, I mean, not considering a huge angle. I mean,
slightly
angle.
Okay, thank you very much.
Okay, thank you.
Any other questions from the audience?
Yes. Hello. Can you hear me?
It's not clear. I mean, could you please speak louder? I mean, there might be a issue with the microphone. Yeah, we are hearing it very little.
Yes. Can you hear me now?
Yeah, I can hear you, but the volume is little lower.
Okay. Let me see.
Pabasara, can you hear the question?
The voice is a little bit lower. That's the problem.
Okay, let's try.
Let's try it. Yeah, Kasan. Yeah.
Yeah.
Okay. Thank you, Pabasara. Thank you for the presentation. Just I have a bit few questions that I wanted to ask you. Who are you designing this system? Is it for the experts or for the lay people?
Sorry, I cannot hear you. Could you?
I mean, what is the purpose of doing this one? For technical purpose or for somebody? Archaeology?
I'm asking whether this was designed for the experts or this is for the lay people.
Yes, only for the archaeologists, not for the general purpose.
Okay, my thing is that considering that the amount of inscriptions discovered in Sri Lanka and the experts are in this field, don't you think that this is, there are enough experts around to do this work? Have you done a user study? Before you start this project, have you done a user study to see whether this is actually needed?
Yes, in the purpose here is to support those experts for better period predictions.
Have you get a feedback from the archaeology department after doing your research?
Yes, sure. From the beginning, they have helped us for this.
And finally, after, so your ultimate results, you discuss with them?
Yes.
So what was the feedback?
They were satisfied with this. And
not just
also,
any archaeologist. What I'm asking is that have you contacted experts on this field? I mean, there are experts, not just any archaeologist. There are experts who can read the inscriptions. So have you tested with them? I mean, is this going to help them? I mean, they are the experts in the field, and there are only few. I mean, considering the amount of inscriptions discovered in Sri Lanka. So. Have you talked to any of them? Have you done a user study with them? Have you talked to them before you start this project?
Yes, I firstly talked with, in here experts mean I have considered the archaeologists. So this is not about...
Really. No, because not just any archaeologist. What I'm talking about is that people who are actually experts at reading inscriptions. There are such people among the archaeologists.
Yes, I have contacted some archaeology researchers, and so only the officials, the educated people there. Yeah. So this is not about.
My concern here is that is there any need for this system? I mean, put aside your methodology and your application.
Yes.
Is there any real need of this system in the field of in the archaeology field? I mean, to the experts, is there any need? Because you are just predicting the period. Predicting the period is something that the experts are doing. I mean, that is what they are expert at. So I'm wondering whether this system is actually needed. Whether you are just doing a research just for the sake of doing something, whether it is actually needed by the experts. That's what I want to know, whether you have...
Maybe expert may not need that one. Maybe other people may be used. If you can come up with application to find out this one, even the new researcher, those who are not having this expertise can be used, this one. But if it is practically what you are doing is correct, that is the main thing, in my opinion.
Yes, but when it comes to the what's traditionally happening here, so period prediction is an initial step before identifying what's on the inscription. That means before the translation. So that's an initial step here. So after examining each letter by the archaeologists, experts, they have to take some very long time for that, maybe months. So as I mentioned here, it gives within seconds, within 10 seconds. So the main purpose here to support them. So before we start everything, we have discussed with those archaeology people, experts, researchers. Then only we came up this idea as support for them.
You haven't mentioned that in your paper or in your presentation that you have actually done a pre-user study, that you actually recognize the need for this system.
Yes, but that's how it happens. We have firstly we made them.
Thank you very much, Babasara. Thank you for the presentation.
Okay, thank you.
Okay, can I ask a question?
Yes, please.
Sure.
Yeah, it seems to be a very useful project to me. What I'm wondering is whether you used any language-oriented or script-oriented features for this in your methodology. What I'm asking is whether your methodology can be applied to any other languages.
Yes. The only difference is they have to, suppose now we have considering another language like
Tamil or something, yeah, whatever it is, yeah, okay.
Some other language like in Myanmar. So the evolution is different than single language.
Yeah.
But we can apply the same methodology for that case also. But maybe based on that problem, we have to adjust some fine tuning here also. So I think this is globally applicable.
So you have to put a framework.
Yeah, what I'm asking is whether so that means you haven't used any features or any art attributes particularly applicable to this particular language.
Yes.
Did you apply? Did you use those features?
I think neural network system itself find those details automatically. I think he didn't do.
Yes.
That's what I'm asking. Whether he particularly used any additional work on that to give the features of a particular language, particular scripts.
The CNN itself work on that, but additionally, in our side, we have focused on character shapes. So we have categorized based on the character shapes with help of archaeology department.
So when you are breaking characters, how do you find the character boundaries?
Yeah, that's a different image processing matter. We don't know too much about that at this point. So how many inputs, initial inputs? How many features in there?
Images, as I mentioned before, it's in the, you mean end-to-end process?
Yeah, I mean initial input to the network.
128, no?
128? No.
That's the size. Yeah. That's the image size.
Not the image size. I mean the number
how many images?
Sizes. Number of inputs to the neural. Yeah.
Yes, we have selected 5,160 images.
Images? You are just giving the images as the input.
Yes.
What about the feature selections? You don't do any feature selection initially.
The features are already categorized.
But that's what I asked. How many features?
Features means based on the character shapes. That means only 5 periods. They are categorized into 5 periods.
The 5 periods are like those are clusters or classifications, right?
Yes, classes.
No, what I'm asking is for your CNN or whatever it is, you have to give some input, right?
Yes. So, my son, the input is image here.
Only the image?
Yes. The CNN itself find the weights and the reaches.
Right, okay. So then in that case, it is applicable to any language.
Yeah, it can be generalized. Yeah, for any other.
Yes.
Okay.
Can be further developed for any other language.
I mean, as it is, it may be applicable. I don't know. If you haven't given any particular script-oriented features, then it should be applicable to any other scripts, right?
Yes, but in here we have created the train model on single scripts only.
Yeah, that I know. That's what I'm wondering, whether it can be applicable to any others. Is Cole not around, right? Dr. Cole? I see. He's here, right? Dr. Cole?
Yes. Yes. It is. So I'm Dr. Gogol. I would like to add more information. The thing is, we didn't add any special features for. It's learned from the raw images.
Right. Okay. So the input is just the image, number of images, right?
Yeah, from the raw images, and I hope that it is applicable for all other languages also. But
all other languages.
Pre-processing and different pre-processing and fine-tuning techniques.
And how did you identify this this period and this period,
Based on the archaeologists, we divide the data set.
Yeah. I mean, they are from their advice, right? Yeah. So, are they happy with the results or the outcome?
Yes. They are satisfied with it. We have acknowledged.
It is, what is the percentage? 90.6 or something?
90.6, yes.
Okay, good work. Thank you.
Okay, thank you.
Okay, any other questions from the audience? Right, it seems.
Kasan, I don't know whether you remember me. And Dr. Mahesh.
Yeah, I remember Dr. Mahesh. I can remember you.
Okay, continue. You better.
Okay,
continue.
Right. Okay. Any other questions? Right, then thank you very much, Pabasara. So I hope you will continue this research and improve it further with all the feedback you receive. So it's clear that we have so many areas to be explored further, and I think this would be a really interesting research and this really useful research for Sri Lankan context. And thank you very much again for your really nice research work you presented here, and good luck for your future endeavors. Right. Let's move into our second paper or the second presentation, which is differential diagnosis of ringworm and eczema using image processing and deep learning. So the presenter here for today is Venuran Nimesh. He's a software engineer, undergraduate at Informatics Institute of Technology, which is affiliated with the University of Westminster. And he's currently working as a full stack developer in the research and development domain. And his research interests are in machine learning and deep learning. So I would like to invite Venura to present his research here, differential diagnosis of ringworm and eczema using image processing and deep learning.
Hi, I'm Venuran Nimesh, a software engineering undergraduate at Informatics Institute of Technology, affiliated with the University of Westminster. My research is about automated differential diagnosis of ringworm and eczema. The agenda of the presentation is as follows. First, I will discuss about the problem background. Then I will discuss about the literature review and the research gap. Later, I will go through the proposed solution, achievements, and the demo of the application. Finally, I will discuss about the technology stack, testing, evaluation, and future enhancements. So what is ringworm and eczema? Ringworm and eczema are a leading pair of dermatological diseases commonly misdiagnosed by doctors due to their visual and non-visual attributes. Both these conditions cause itchiness, redness, and circular rashes. Ringworm is a fungal infection, while eczema is caused by a bacterium. Even though they portray the same, their risk factors and treatments are completely different. So what happens if doctors misdiagnose these two conditions? Normally, for a bacterium condition like eczema, steroid creams used as a treatment. But if this cream or the other treatments were given for ringworm after misdiagnosing, the ringworm condition becomes worse like the below image. Here you can see this is the initial stage of ringworm, while this condition is after using the wrong treatments. These types of conditions are even complicated for experienced dermatologists to diagnose. Since this problem is related to the medical field, there are some solutions invented from the medical side. First one is meeting an experienced dermatologist. This is the most accurate approach, but this is not affordable for every patient. The second approach is using teledermatology. This costs more than meeting a dermatologist since this type of service is provided by dermatologists. Also, with the shortage of dermatologists, this approach is not applicable for developing countries like Sri Lanka. Third and the fourth approaches are using dermoscopy and sonogram machines. Both these equipments are lacked in developing countries due to their high cost. So now we will go through the digital image processing researches that have done in the recent past for this disease combination. Dermatological disease diagnosis using color images by Shamsul Arfin is a popular research conducted considering commonly misdiagnosed diseases. This was able to acquire 88% accuracy. For testing, it was considered only 25 patients and the images were captured using a DSLR camera. So this system works only with high-resolution images. Another research project is skin disease recognition method based on image, color, and texture features by Wei, Gan, and G. It was able to obtain 85% accuracy. This accuracy was obtained only after tested for 20 samples. Also, they have not mentioned about their data set, which was used to train the system. Skin diseases classification using local binary pattern and convolutional neural network by Akmalia, Shihoming, and Suherman was only able to acquire 80% accuracy. One of the advantages of this research project is that they have considered 6 skin diseases. But this system also works only with high-resolution images. Though the attempts made at diagnosing dermatological diseases using image processing techniques and machine learning have increased in the past few years, but the majority of the research projects were focused on diseases that visually look different from each other, like melanoma and basal cell carcinoma. Only few research projects were considered for common dermatological diseases and commonly misdiagnosed disease combinations. Most of the existing systems works only with high-resolution images. Another research gap that I have been identified is the existing systems not implemented their systems with the proper image data set, including different skin tones. So this is the proposed solution to overcome the above issue. Image processing techniques with a deep learning neural network was designed. The dataset was created by collecting images from doctors and scraping through online medical atlases, and the deep learning model was trained using the novel dataset. Now we will see how the proposed solution works. Normally, if a patient discomfort, they immediately visit a hospital or their family doctor. If the doctor is confused whether the condition is ringworm or eczema, he can capture an image and upload to the server. Then the image will be pre-processed, and using the implemented neural network, it will classify the disease and send back to the user. The achievement of this research project is a novel dataset was created by scraping images from online medical atlases and collecting from dermatologists. 2,755 images are contained in the dataset, including different skin tone images, lesion images at different locations of the body, images under different lighting conditions, different resolution images. A deep learning neural network was designed and developed from scratch and hosted on a server to classify the disease combination. 82% accuracy was achieved after testing the implemented system for more than 650 images. Now, quickly we will go through the demo of the implemented mobile application. As the front end of the system, an Android application was developed since most of the end users preferred to have a mobile application rather than having a desktop application. In order to connect the Android application and the hosted model, a Flask API was written using Python. As you can see, a simple UI was designed to ensure user-friendliness of the application, as this will be mainly used by doctors. A user can capture an image through this application itself. Or he can choose an image from the photo gallery. These captured or selected images are displayed and they can be uploaded to the server. The most important classification part starts hereafter. The uploaded image is pre-processed to remove unwanted noises before being sent to the deep learning model, which is already trained to classify this disease combination. Then, the diagnosis outcome is displayed to the user. The treatments for these disorders are also available. Now we will test the application for some of the other images also. This is an eczema lesion which is very close to ringworm from their visual appearance. However, the system is capable of correctly diagnosing this image as eczema. This is another eczema image, and this is also identified correctly. This is a ringworm lesion at its initial stage, and it is diagnosed correctly. This is the same ringworm lesion that got worse when it was misdiagnosed and treated incorrectly. Even experienced doctors are confused by this complicated situation. However, the system is still capable of accurately diagnosing this. So if we consider the technologies behind this proposed solution, Android was used to create the front end of the application. Flask was used for the front-end back-end communication. Python, Keras, TensorFlow were used for the back-end. And Google Colab was used to train the neural network. And in the data tier, for project versioning, I have used GitHub. The performance of the implemented model was measured by analyzing the accuracy and loss curves, comparing the training set performance against the testing set. It was able to get an accuracy of 85% as the training accuracy and 82% as the validation accuracy. The below graph displays the model accuracy of the implemented system. The performance of the implemented mobile application was measured by feeding various image formats and resolutions. This was done to determine the supported image formats and resolution images that were supported. The below table ensures that the system works with most common image formats, different resolution, and different image sizes. The implemented system was tested in front of some dermatologists and few other doctors, and all of them were happy with the performance and the accuracy of the system. They suggested some future enhancements that can be added to the system in the future. Some of them are flexible diseases. Adding multiple common misdiagnosis diseases and other forms of dermatological diseases to the system. This will greatly increase the functionality of the application. Real-time classification. A real-time classification system would be more preferable because then the end user doesn't need to capture and upload images to the server and wait for the diagnosis result. Even without capturing the images, the system will diagnose the disease while the camera app is open. Increase accuracy and performance. Although the prototype's accuracy is adequate, it can still be improved by optimizing the dataset, hyperparameter tuning, and including more convolutional layers to the deep learning model. Mobile platform. Develop the application to other mobile platforms like iOS, as some users may not use in the Android platform. So thank you.
Okay, thank you, Venura. And now the audience can raise your voice for the questions, and if you need clarifications related to the presentation or the research, you can ask your questions, clarification from the Venura.
I have a quick and simple question. Hello?
Yes, sir. Yeah, Dr. Mahesh, we can hear you.
Yeah. Who evaluated the system finally?
Sorry, sir?
Who evaluated your system, whether your system was correct or not?
Yeah, I have shown this system to some dermatologists and doctors. Sir.
Some.
Sorry?
You said some. You said some people, right? Who evaluated? I couldn't hear.
Can you hear, sir?
Yeah, yes, but yeah. So you said doctors or some people, other people?
Doctors and both doctors and dermatologists, sir. Before I start the research, I have conducted a survey with dermatologists and doctors. After the results, I have chosen these two diseases combination. and after completing the system also, I have evaluated with them also, the dermatologists
Okay.
and doctors.
Okay, so you should give prominent to that, because the system at the end depends on their evaluation, right?
Yeah.
Yeah, it is important who evaluates the system. Okay, that's okay. Then.
Any other questions from the audience? Okay, while others are coming up with their questions, I will ask a question from Vendra. So Vendra, so here the neural network architecture is basically the convolutional neural network, right?
Yes, sir.
Any particular reason for going for that CNN architecture? Because there are, I mean, lots of improved versions of neural network architectures, deep learning architectures. So any particular reason for going for that specific question?
In the literature review, I have found that SVM and artificial neural network AN was not performed well with this, so I have chosen CNNs.
Okay. And probably you can try out different, latest architectures and compare your results and look at what performs better in future. Right. If there are no more questions, we can go for the next presentation. Right. Thank you, everyone. And I hope you would improve your research in future and be a real good prospect for Sri Lanka as a researcher. Thank you very much. And for the next presentation, I would like to invite Vigneshwaran Palanisamy. He's from Department of Computing and Information Systems, Sabaragamu University, and the research he's going to present is detection of wildlife animals using deep learning approaches. This one is a review, systematic review. So let's see the review outcome of this paper. Vigneshwaran, please start your presentation.
Hello everyone, I am going to present about our research. Our research is detection of wildlife animals using deep learning approaches as systematic review. These are the outline of this research: introduction in deep learning algorithms, wildlife monitoring environment and data, systematic review, evaluation and discussion of the results, recommendation for the future direction, and conclusion. Let's move to the introduction part. Let me explain about why we need wildlife animal detection. First thing is there should be a system for monitor the distribution for conservation of animal life for track the animals' behaviors and movements. And nowadays there are some road accident occurs for wild animals. To avoid those accidents, we need a standard automated wildlife animal detector. In earlier stages, these detection happen based on the camera traps that are activated in the field which animals enters without disturbing them. It has been discovered with several steps like recognition, classification, detection, and tracking. To detect the wild animals, there are some traditional methods and machine learning methods have been used. Traditional methods are used for this purpose: light detection, airborne, remote sensing images, micro Doppler signals, sensor, radio frequency identification, and GPS technologies. Likewise, there are some other methods as well used. Likewise, there are some other methods have been used based on the machine learning. Those methods are random forest, k nearest neighbors algorithm, shift, as well as support vector machine. Among these methods, deep learning provides extraordinary powerful mechanism in terms of accuracy. Deep learning incorporates with multiple layers of features or representation of data to get cutting edge results. To recognize, classify the animals, there are some convolutional neural networks such as AlexaNet, VGGNet, GoogleNet, and ResNet has been used. For the object identification, faster recurrent convolutional neural network and YOLO has been used. For this purpose of wildlife animal detection and monitoring the things, there are three things will be considerable. Those three things are fast and powerful hardware structure, software algorithm that can be well processed on this computational architecture like parallel processing and general purpose graphics processing unit, and a big amount of training data. If you think about convolutional neural network, they are regularized version of multi-layer perception. Multi-layer perception usually mean fully connected networks. That is, each neuron is one layer is connected to all neurons in the next layer. If you think about the sample deep learning structure of identifying wild animals, the input image will be given as input pixel. By using some hidden layers, the object features will be extracted, and like this probability mechanism, it will be the output will be met. Likewise, if you think about the sample CNN architecture, image will be given as an input in the convolutional layer. All the pixels will be converted into its respective field into a single value. Pooling layer will feature maps that summarize the presence of those features in the input. By using activation function, can check linearity of the image. In this table, we have explained some CNN models. Say for example, if you think about AlexNet, it has used salient feature of deeper, and the basic structure of AlexNet is it has concerned with 5 convolution layer, 1 exploring layer, and the activation of function of review layer, and it has connected with 3 fully connected layer. From this top 5 accuracy, it has got 84.7%. Likewise, there are some other models has been used, but they have got the high accuracy rather than comparing with AlexNet. Detection of animals using camera trap images or video is a challenging task because here there are low contrast between foreground animals as well as cluttered backdrop, and they have shown significant number of false positive due to dynamic environment, swaying trees, rippling water, moving shadow, sunspot, rain, and other elements in video recorded by using natural settings of huge class of demanding situations. And there are some different data sets as well. SSC data set. If you think about the SSC data set, it was gathered using 225 video traps set up in the Tanzania's SSC National Park. More than 1 million sets of photographs were captured there, and each photographs include 13 images. Likewise, NACTA contains 3.7 million camera trap photos from 5 locations around the United States, with the 28 animals type was labeled. This picture shows how wildlife animals are captured by camera trap. This study is preliminary study for my MSc project, detection of Sri Lankan elephants using deep learning approaches. Here we survey the major deep learning ideas relevant to the detection and recognition of wildlife animals. Here we have analyzed the comprehensive evaluation and comparison of these approaches. The open challenges and prospective research directions are discussed here. Based on our knowledge, this is the first attempt to review deep learning algorithms for recognizing and detecting wildlife animals. Our analysis based on the different benchmark data sets like SSC dataset and other data sets as well. If you think about the SSC dataset, there are SSC dataset used with 2 different number of count in species. One is 26 number of species, another one is 48 number of species. While change the number of count in species, the same data set, it has shown variation in top 1 as well as top 5 accuracy. Say for example, if you think about the 26 species, or the top 1 accuracy is 88.9% and top 5 accuracy is 98.1%. But for the 40 species, top 1 accuracy is 58.9%, but top 5 accuracy is 80.9%. Likewise, there are some other data set has been used like Renox, snapshot CRT, and EMAML machine learning, NACTI, and Caltech camera trap data as used for this task as well. The overall purpose of this study is to analyze the contribution and approaches have been used for deep learning algorithms in wildlife animals, recognition, detection using camera traps data. Deep learning and convolutional neural networks have outperformed the state of art in detecting wildlife species. For this purpose, deep learning approaches are divided into two groups: regional purpose-based methods and classification-based methods. Recurrential convolutional neural network and fast recurrential convolutional neural network comes under the region purpose-based methods, and YOLO and SST comes under the classification-based method. CNN models based building block is convolution layer. It can determine the output linked input and output determined by nonlinearity layers like sigmoid, logistic, and TAN and ELU and others. There are some different BL models used for wild animal detection with the different objectives. Say for an example, AlexaNet 8, VGGNet 16, GoogleNet 22, and RustNet 50 has been used for the objective to overcome the objective of automated species classification with the help of SSC dataset with 26 species, and they have got the 89% of accuracy. Likewise, fast RCNN and YOLO version 2 has been used for the objective for identify, quantify, and localize animal species with the help of SSC 48 species dataset, and they have got the accuracy of 76.7%. Likewise, fast RCNN was being used for the objective of animal detection and counting with the help of SSD dataset, and they have got 90% of accuracy. There are some huge important outcomes and analysis from the deep learning methods on wild animal detection have been occurred. Say for an example, there is a method used for get the outcome of preferable to use the segmented data set. With that, we will have a higher level of precision. If the models can find the creators or parts of them, then they can apply classification to these pieces. With that, there are some different scenarios and achievement has been occurred. Use deep convolution layers like AlexaNet, VGGNet, GoogleNet, and RustNet to classify photos captured by camera traps on a variety of data set. With the help of data set means unbalanced and balanced, conditioned and segmented data set has been used here. Likewise, there are some different variation of outcomes has been occurred with different methods. Likewise, they have achieved different scenarios and achievement in these methods. From this systematic review, we have analyzed for the animal detection, there should be a need of standard model for huge data set. Since lightweight deep learning models like MobileNet and EfficientNet use fewer parameters and that makes improved classification accuracy, these models can boost up the accuracy of standard automated system for zoologists. Especially the unique feature of MobileNet requires very little computer power to perform transfer learning. It can be used to increase the considerable accuracy in animal detection. In future, using transfer learning with the help of data augmentation techniques that can be increase the learning and that can be make the models that are used in the existing research or existing data will be more suitable for this task. The overall objective of this review paper is highlight the contribution of deep learning algorithms, wildlife animals, recognition and detection of using camera traps data. For this reviews, we have discussed what are the approaches existing researchers used for this task and analyze the compared these approaches of solution to see their shortcomings. This review can facilitate the researchers to enhance their study in deep learning methods, particularly with the help of camera trap images and to identify the wildlife animal recognition and detection in the camera trap images. These are some references we have used for this research. That's all for the presentation. If you have any question, you can ask now.
Right, as Vignesharan said, it's time for questions. And if you have questions, please bring it here so we can, Vignesharan can help you to clarify things. Okay, Vignesharan, one question from me. Did you identify any gaps or future directions that the researchers can further explore in future based on your review?
So, good, am I audible, sir? Before
Yes,
that question,
yes, Vignesh.
am I audible, sir? So,
Yeah.
it's a great pleasure to present my presentation in the 2021 and great pleasure to see you also. And yeah, so we have started this study, basically this review for future work. So, especially currently we are working on the automatics element identification regarding to the EA images. For that purpose, we have to know what are the existing studies related to the animals. So related to animal species identification. Yeah, so with that, we have observed some research gaps. So based on the data, especially based on the data set, some data sets are some suitable, some models. So say for example, the SSE data set they have used for the two different types of count in the species. Say for example, 26 species as well as 48 species. If we use the 26 species, it has of course the high accuracy. Likewise, if we use the 48 species, it has of course we have observed like that. So it has occurred the low accuracies. So like that, it has shown some various difference in the models as well as the data, especially the data set. Likewise, if you think about we have from the analysis, we have got that there are some these analyses are not straightforward. So we have analyzed that it is not a straightforward. So if you use the transfer learning techniques in the future, if you use the transfer learning techniques like mobile net, efficient net like that, and if you integrate with data augmentation with that, and it will be more provide the higher accuracy rather than comparing with existing accuracies.
Hello, can you hear me?
Yes, we can hear you.
Hi, I'm Damayanti, joining from University of Peradeniya, and it's great to know about this work. And I have one question. I was a little bit late to join the presentation, so pardon me if repeating something was mentioned in the presentation. My question is, did you realize that there are certain locations in the globe that these kind of studies have been done? I mean, and you were discussing about data augmentation. So what is the data size that we are considering here in this kind of generally so far?
No, normally the future activities we have suggested like this data augmentation, because in earlier things they are from our analysis didn't use the data augmentation techniques. So that's why we have in the future.
Right. My question is, in the previous work, generally what is the data size, or what are the sort of locations? I mean, was there any study specific to Sri Lanka or?
Yeah, the data sets are normally provided in that. I have mentioned that the SST data set is provided in the Canada, US, that forest set. Like that, we have analyzed, not from the Sri Lankan, not from the Sri Lankans. We have analyzed the various data sets like from the Canada forest, US forest, like that.
Okay, thank you.
Okay, if there are no questions, thank you very much, Vigneshwaran. And I hope you would continue on these works and come up with a better and improved research in the next year ICTE conference. So we are waiting for your research in the next conference as well. Thank you very much, Vigneshwaran.
Oh, thank you, sir. Thank you for this.
Yeah, the next is a paper, a rule-based approach for detection and correction of grammar errors in written active voice Sinhala sentences. And the presenter is VP Uresha Sevandi. Is a final year undergraduate of Department of Interdisciplinary Studies, Faculty of Information Technology, University of Maratua. And her research interests are in natural language processing, and specifically in Sinhala language. So, Uresha, so you can start your presentation.
Hi everyone, I am Uresha Sevandi, an undergraduate faculty of Information Technology, University of Maratua. My research topic is a role-based approach for detection and correction of grammar errors in written active voice Sinhala sentences. Moving to introduction, Sinhala language is the official language of Sri Lanka and it is the medium of instruction in most private and state schools. The Grade 5 scholarship examination is one of the competitive examinations held in Sri Lanka and around 76% of candidates faced for this examination by Sinhala medium. At the scholarship exam, candidates should write 3 sentences to obtain 6 marks for the compulsory essay question and it is considerable mark. Then we have to clarify why we are targeting this essay question, because each year approximately 83% of students obtain 0 marks at the exam for this essay question. When examining the marking rubric of the essay type question, clearly a great percentage has allocated to the accuracy of grammar. Furthermore, grade 5 students should have proper practice with essay writing to face the essay question while avoiding common mistakes. Moving to problem in brief, we have identified common mistakes done by the candidates during the exam, such as confusing sentences, spelling errors, grammar errors, repetition errors, and colloquial language use. Traditionally, students too much depends on their teachers to correct written essays and do not have opportunity to self-learning and self-evaluating their essays. Moreover, lack of tools available to detect Sinhala grammar errors and provide suggestions for incorrect grammar in typed sentences for primary students to improve their usage of accurate Sinhala grammar. Further, this grammar module has designed as a part of grade 5 essay marking system. Then, let's see how we can address this problem. We have designed our grammar module under 2 major components, such as grammar error detection and grammar error correction. Hello. Hello. Hello, can you hear me?
Hello, yes, Suresh. We can hear you.
Sudden power cut happened for me.
I think many have faced the same issue. Let's wait until a few more people join and we'll again resume the presentation.
Okay, thank you.
Hello, yes, Suresh. We can hear you.
Yes. Hello.
Hello? ඔව් කවුද මේ? ඒක තමයි මම ප්‍රශ්නයක් අහන්න ගියේ මේ ටග්ගල් කට්ටුනා මේ වටේම ගිහිල්ලා ඔයගොල්ලෝ ගිහිල්ලාද? ඒක තමයි දැන් මගේ questions ඒකේ questions අහන්න බැරුණා මම තබෝට මම දැන් ආවා මේකෙන් මේ මගේ ටැබ් එකෙන්. නමුත් මම දැන් බැලුවාම අනිත් ඔය 3
Moderator, My research topic is a rule-based approach for detection and correction of grammar errors in written active voice Sinhala sentences. Moving to introduction, Sinhala language is the official language of Sri Lanka and it is the medium of instruction in most private and state schools. The Grade 5 scholarship examination is one of the competitive examinations held in Sri Lanka and around 76% of candidates faced for this examination by Sinhala medium. Accuracy of grammar. Furthermore, grade 5 students should have proper practice with essay writing to face the essay question while avoiding common mistakes.
We are very sorry for the inconvenience. There's a small issue with the connection. So we will be starting again with our next presenter's presentation.
The accuracy of grammar. Furthermore, grade 5 students should have proper practice with essay writing to face the essay question while avoiding common mistakes. Moving to problem in brief, we have identified common mistakes done by the candidates during the exam, such as confusing sentences, spelling errors, grammar errors, repetition errors, and colloquial language use. Traditionally, students too much depends on their teachers to correct written essays and do not have opportunity to self-learning and self-evaluating their essays. Moreover, lack of tools available to detect Sinhala grammar errors and provide suggestions for incorrect grammar in typed sentences for primary students to improve their usage of accurate Sinhala grammar. Further, this grammar module has designed as a part of grade 5 essay marking system. Then, let's see how we can address this problem. We have designed our grammar module under two major components, such as grammar error detection and grammar error correction. The grammar error detection consists of error type identification and assign final grammar module mark. Then the grammar error correction component will provide suggestions. My paper describes what are the current researches available and what are the drawbacks of each and every item, and commonly, I can say these are major drawbacks of those studies which are not touched up to the level required Sinhala grammar. The objectives of this proposed system you can identify as detect grammatical errors within a defined scope in given Sinhala sentences, identify error type of detected grammatical errors, provide suggestions to correct identify grammatical errors, assign marks for an essay considering grammar, and develop a web-based application which users are able to input their Sinhala sentences. Moving to grammar error detection and correction module, here consider only active voice sentences, present tense and past tense as tense-wise, singular and plural as number-wise, masculine and feminine as gender-wise, indeterminate category, first person, second person, third person category, under person category. The input of grammar module is spell correct post-tag sentences. The process consists of pre-processing, grammar error detection, error tag identification, give suggestions for grammatically incorrect sentences, and allocate final module mark. To implement this, I have chosen a rule-based approach because our system has implemented for Sinhala language and Sinhala has clearly defined set of rules. This is easy to understand. Rule-based system is more transparent and errors are easier to debug, like easy to add, remove, or edit, accuracy able to improve, and understanding more rules. Moving to higher level flowchart of the grammar module, you can see grammar error detection has implemented with the set of rules matching with database and grammar suggestion module use both database and corpus along with the rules. This is the detailed diagram of the grammar module. Moving forward, at the pre-processing, the input spell correct post-tag sentences and sentence tokenization, word tokenization, and subject identification happen here. This is an example for addressing free word order problem, and you can see the system generated output like this. Grammar error detection happen under two main processes here, as subject pattern identification and verb pattern identification. Moving to subject pattern identification, only identify a subject in the sentence is not enough to check sentence against, because it depends on the subject pattern, the predicate will be changed. So for a user type sentence, word available in the sentence and depends on the before word samuhavasi, the subject pattern able to decide. Tharupela has a babalai kind of, when we take an example like Tharupela babalai, here the before word for the Samuhavaji is Taro, that is innominate one, and subject pattern will able to identify as sentence like Lamai Pela Pasalyati. The before word for the Samuhavaji is Lamai, and that is animate one, and subject pattern is subject masculine plural without edit. Then you can check with here, every noun should consist with hope like Mama ho piya ho gedare yami. This sentence with step, if still unable to find the subject pattern, we can check the probability of infinite words, and based on that, we can decide the predicate, like Udayasanas were the multiple. Here, is inanimate and it's the related to this, and we take a sentence as like plural without adding. If we are still unable to find a subject pattern, remove common errors and take them to decide the subject pattern happen in this step. Then, at the next step, if still unable to find the subject pattern, we can check for availability of indefinite words, and based on that, we can decide the predicate, like Udayasanas were the multiple. Here, mul is inanimate and it is plural. The subject pattern related to this sentence is able to identify as inanimate plural without edit. And when we take a sentence as like Rajvi has a Sanda Papala, Sanda is inanimate, also this is singular, and related subject pattern is inanimate singular without edit. At the final step, we can identify subject. If we are unable to identify subject pattern still, then we can check whether object if we are able to identify, like upper validity and salaki yuttu kind of sentence we can consider here. After this level, we check all these possibilities to identify subject pattern and fit for the grade 5 students within our defined scope. After identify the verb in a sentence, then that should match with the previously identified subject pattern along with the verb ending patterns at the database. If we still unable to find a subject pattern, then we remove common errors and take them to decide the subject pattern. If the basic subject verb in this step, okay, then first check for preposition rule against both. At the next step, if still unable to find the subject pattern, we can check for availability of indefinite words, and based on that, we can decide the predicate, like Udayasanas were the multiple. If the both here, mul is inanimate and it is plural, then we can the subject pattern related to this sentence is able to identify as inanimate plural without edit. And when we take a sentence as these like are the examples Sanda is inanimate, also this is singular, and related subject pattern is inanimate singular without edit. As essay topic. At the final step, input several we can identify subject. After if we are unable to identify subject pattern, we can still system generate. Then we can check whether object moving to error type able to identify like upper validity and selecting the kind of sameness we can consider here. After this level, we check all these possibilities to identify subject patterns and system fit for the grade 5 students within our defined scope. Error types and providers. After identify the verb in the sentence, then that will be natural without identify subject pattern along with the verb ending patterns at the database. Second person, and if we still unable to find a subject pattern, then we use common errors and take them beside the subject. The basic subject verb which is that first system generated against both. At the next step, if we still unable to find the subject pattern, we can check for availability of indefinite words, and based on that, we can decide the predicate. Like Udasana Swadamante, if the boy here is inanimate and it is plural, then we can subject that is related to this sentence able to identify as inanimate plural without any words. And when we take a sentence as these are the examples of the popular and is inanimate, also this is singular and related subject pattern is inanimate singular without any essay topic. At the final step, input several we can identify subject. After if we are unable to identify subject pattern then we can check whether object moving to error type are able to identify like upper validity and selecting the kind of sameness we can consider here. After this level, we check all these possibilities to identify subject pattern and system fit for the grade 5 students within our defined scope. Error types and providers. After identify the verb in the sameness solution, then that will be natural without identify subject pattern along with the verb ending patterns at the second person. And if we still unable to find a subject pattern, then we use common errors and grammar beside the subject. The basic subject verb first system generated against both. At the next step, if we still unable to find the subject pattern, we can check for availability of indefinite words, and based on that, we can decide the predicate. Like Udasana Swadamante, if the boy here is inanimate and it is plural, then we can subject that is related to this sentence able to identify as inanimate plural without any words. And when we take a sentence as these are the examples of the popular and is inanimate, also this is singular and related subject is inanimate singular without any essay topic. At the final step, input several we can identify subject. After if we are unable to identify subject pattern or we can check whether object moving to error type are able to identify upper validity and selecting the kind of sameness we can consider here. After this level, we check all these possibilities to identify subject pattern and system fit for the grade 5 students within our defined scope. Error types and providers. After identify the verb in the sameness solution, then that will be natural without identify subject pattern along with the verb ending patterns at the second person. Other than you have common errors and